Welcome everyone to MATHurdays. So excited that you are here and that you are able to join us today on Saturday. We have quite a packed hour of awesome math learning. We're going to start off with a math routine. Every week I try to showcase another routine that you're probably already familiar with in the face-to-face classroom and give you some new ideas about structures that you can implement online to get more interaction, collaboration, and student voice. And then these structures aren't, hard and fast rules for each of them. I just try and showcase something a little bit different each time to add to your repertoire of online tools. So let's dive right on in. You're going to need access to the interactive slides, and I'm going to put that link in the chat box. Make sure you have that open. That's where you're going to do most of your work. And you'll notice on slide 1, I have several ways for you to stay in touch through email, website, Twitter handle, and YouTube channel. And today's activities are from other resources. I didn't create anything for this. I used numberless word problems, and their site is linked there. And I've used the Rich Math Tasks from the Virginia Department of Education's Rich Tasks. So I'm here to showcase both of these today. But before we begin, let's get to know a little bit about each other on slides 3 or 4 or 5. Go ahead and share with us something about you, a success or a celebration. It can be about your personal life, your professional life, your math life. And in this case, since we're doing a problem on motorcycles, I decided to show you all Bumblebee. This is my Triumph Street Cup, and it is an absolute joy to ride. And as these are coming in, I'll invite several of you to turn on your microphone and elaborate a little more. Molly, how's your morning going? How's the card writing going? They're always such a joy to receive.
It is going well. It's a nice kind of low-key weekend for us and nice and sunny, but a little chilly out there. So it's nice to get out for a walk and then have some time to write some cards.
Yay, I just did one this morning also. Always inspired when I see one of yours. Someone on slide 5 is writing that they had a positive 4th week of virtual teaching and even a mini assessment. Would you elaborate? Tell us a little bit more about that.
Okay, good morning. I teach math and computer science in Alexandria, Virginia. So yeah, it's positive because it's amazing how you can still really develop relationships with the kids. Like, so I've been with them 4 weeks, and I'm becoming familiar with their personalities, and so we are really forming a group. I've been doing a lot of community building and in warm-ups, and so I think it's paying off. And then the mini assessment, it was I did like a breakout room type of thing where they had to do 4 problems and get numbers from it, and then they put those numbers in a code and then got to another slide. But what was fun about it is hearing them work on paper and pencil in the background, because I missed that sound. When they had a question, they would I would hear them erasing and writing, so that was positive for me too.
Oh, thank you for sharing. Yeah, there's, teaching online is different, and the interactions that you seen before will come out a little differently here. So it is definitely different, and excited to hear about your successes. Somebody is new in their role as a K2 math coach, and tell us how it is developing relationships in your new role.
Hi, that's me. This is Stephanie. Yeah, we are starting off the year all remote, so I think that what I've done to develop relationships is just really be available for teachers and be in their virtual classrooms on a regular basis to just introduce myself to kids, to model something, to introduce a new, I don't know what you call it, a new online program that we're rolling out this year. So I think just supporting them in that way and just offering resources, a lot of your stuff actually. So that's been really positive. I feel like I've gotten to know people pretty quickly, and I was a little nervous how that would go.
Yeah, online communities and building relationships online has been something that I find very natural, but I'll tell you why I
Mm.
find it to be natural. And it's because I used to be a really big video gamer. I used to play World of Warcraft for like 5 hours every single day. So I was seriously committed. And we had a guild, we had a group of people. 50 of us would come together to go battle this monster. And, we had to find time to talk about personal stuff, family things, what's going on in our lives, and then get serious and then joke around when there was joking time. And these folks became like my second family. So, there's interesting ways that we build relationships, but it's just different than in face to face.
Mm.
Thanks for sharing.
Sure.
And Lara, I would love to hear the way that you say the name of this hometown. Tell us a little bit about the coffee you found.
Good morning, Teresa. So my family is from Nicaragua, and they have a coffee plantation outside of Matagalpa in Nicaragua, which is very close to where this blend from Trader Joe's is. So we all marched over to Trader Joe's just to take pictures this morning.
Oh, so lovely. I love the language and listening to you say it too. So wonderful. Well, thanks everyone for sharing a little bit of yourself with us here. We're going to jump right in to our routine and our task. On slide 6, we have a link to the routine numberless word problems, and I used the same problem that they did in this video. So if you want to see it in a face-to-face class, here's the link. If you're going to use this recording for your professional development, you can even have teachers compare and contrast the face-to-face classroom and the online. On slide 7, I have, not a hard, fast protocol, but the protocol that I'm choosing to use today. So in numberless word problems, I'm going to start off with a color coding and asking you, what questions could be asked. I'll have you share your questions in pair shares. We'll get new information through a text box, and then the idea of like, why are all these possible? So this is the protocol I'm going to use, and let's give it a whirl. Alrighty, join me down on slide 8. To take that part out. There we go. On slide 8, if you could please take over one of those text boxes. Instead of the word student, it'd be lovely to have your name in there. And that's going to be your space, more like your carpet spot or the dot in line. And I would typically have this done for my students if I had a class roster. Alrighty. So on slide 8, this is your space. And we're going to start off with these two sentences. Isaac found some seashells at the beach. Isaac found more seashells than Kira. I'm going to ask you at this point, what questions could be asked? So given this, what kinds of questions could we ask? If you have one idea, you're going to start at the top of the rainbow and color code red. If you have 2 questions that you could ask about this numberless word problem, you're going to change it to orange. If you think of 3 mathy questions you could ask, you're going to change it to yellow. And we're going to keep moving through the rainbow. As you have more questions you could ask, you can change it to another color. And these colors let me know right away how many ideas people have. I'm going to pop you in breakout rooms. You're going to be with exactly one other person. So these are just a quick pair share, and it's only going to be for 2 minutes. You're going to share all the questions you think you could ask about this problem. During this time, if you find that your partner is disconnected or is not interacting, you have the ability to move yourself into another breakout room, so please don't be all alone. All right, turn on your microphones and share the questions you could ask now. If you are watching this remotely, there are some things that I am doing right now. I'm ensuring that the microphone is on for each pair. And if I see that it's not, I'm going to assume that that person is by themselves, and I'm going to regroup them with other people. And I also am noticing new people who come in, and I want to get them into a group. Hi, Branch. Do you remember who you were working with when you were last in here? I'm going to put you in group 1 just so you have some buddies. And I also typically spend time moving in and out of these rooms and listening in on them.
And just see if they would like to share. No, it's just us.
It's Teresa. Look at that picture.
Hello. Just come
That's a really
out.
cool picture.
My daughter was face painting. I had to put it up here.
That is
That's
so
funny.
cool. I love how your daughters are so creative, just like you.
Welcome back, everyone, to the main room. We're all back together now. Hello, hello, and welcome back. And now, typically in a class, I might have students raise their hands and we can share that way. There's different ways we could share it. What I would like to know is on the next slide. So if you find that your question is kind of answered here, feel free to put in the chat box a little emoji connection. Alrighty, I'm on slide 9. I invite you down here. And our new piece of information is on here. It says, Isaac found 20 seashells at the beach. Isaac found more seashells than Kira. How many seashells could Kira have? If you would take over one of those little text boxes and put a number in there, and then if you see another number that you agree with, you are welcome to turn that number bold. And bold will be our signal that we made a connection with somebody else and we agree with that. You'll also notice in the little corner there, I have a thinking emoji. He's off of the slide, just off to the side. And if there's one that you're like, I disagree with, or I'm not sure, or I need an explanation, feel free to drag that emoji down to any of the ones that you might feel that way. And we'll start off with this bold one. Somebody put this here. If this is your 15, I invite you to turn on your microphone and tell us why this is a possible answer.
Pretty sure that was my 15. I just knew it was less than what Isaac had with 20. And now that I think about it, I mean, it seemed kind of random, but now I see that they're both groups of 5. So I wonder if that kind of like, I naturally thought of like one less group of 5. That was my 15.
Neat. And some people put 1 in bold also. If this is your green piece here, would you like to share with us why do you think 1 could be a possible answer?
I know that 1 is less than 20, so that could be the number of seashells that Kira has, because that would meet the conditions and the problem of Isaac finding more than Kira.
Ah. And we even have some that say or less, or they are a range. If you were one of the people who have it in yellow, I invite you to turn on your microphone and share with us what does this mean, and why isn't it just one number?
This is Jerry. I was just thinking of the range of possible numbers.
And what
So
does range mean to you?
the maximum amount of seashells down to the minimum amount of seashells.
Ah. And we can get into some really neat number sense here. We can talk about the number 1 being the lowest and have a rationale for that. We can talk about the number 0. We could even get into negative numbers and would they exist in this problem. So for those of you who are teaching number sets, especially in that middle school range, this becomes an important topic. All right, folks, so this is just the numberless word problems in a bit of a more structure. And on slide 7, I have the different structures that I used here. Hopefully you will find that by mixing and matching structures in different routines, kids will find that they're different, fun, and interactive. All right, so let's get into our task. If you join me on slide 11 first, I want to talk about some research. We don't just do rich tasks because they're fun, because that's the reason I would do them. We also do them because according to NCTM's publication of Principles to Action, these 8 math teaching practices are what are needed for student understanding. Today you'll see all of these, and I will highlight the last one, elicit and use student evidence of student thinking during our math talk. So as we begin, I'm going to share a problem-solving oath on slide 12. As I read this aloud, read it to yourself. And if you agree to this oath today, you may pledge it by writing your name in the chat box. I, Teresa, promise to try my best. I will make sense of patterns and numbers. I will use manipulatives and drawings. I will make mistakes. I will ask questions. I will listen to other ideas. I will stay engaged by always trying to find another solution or representation. I am a problem solver. I make the world a better place. Look at all these wonderful problem solvers. Congrats on taking that pledge today. On slide 13, I have some choice manipulatives you might choose to start with, but you don't have to go with these. They're just ones that work really well for the problem. And dun, 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 our problem is on slide 14. This comes from the Virginia Department of Education in their rich tasks. I've put the link below so you can get to it. And it says, all 20 spaces of my favorite parking lot are filled by vehicles. Some were occupied by two-wheeled motorcycles and others by cars. Each space has only one vehicle occupying it. Oh, to calm myself, I counted wheels, and there were exactly 66. How many cars and how many motorcycles have parked in my lot? That's our task. group slides are below. I'll be sure to let you know what group you're in. If you're unable to figure that out, I'll be down there and letting you know. If you do know, please make sure the rest of your group members also know. Turn on your microphones and have fun. Go get messy with the math. Here we go. If you're watching this from home, at this point, the participants have moved down into their breakout rooms. My job has really just begun. At this point, I'm going to be monitoring these rooms and all the things that are appearing on them. I'm looking specifically for different models that are going to showcase this idea of the variable being either 2 or 4. And we might even see some fractional concepts that come out of 1/4 and 1/2. I'm also going to be looking for tables, graphs, and equations because as much as this looks like an elementary school problem, it is listed in the Algebra 1 standards. So I've got a busy job here. I'm going to be moving around rooms, talking to people, and looking for these representations.
Says group 5 at this. Yeah. Do we want to put our names next to group 5?
You just read my mind.
Oh, perfect.
Yeah. Now, I realize whenever I haven't added a place for my students to put their name on some of their group work, and I'm regretting that. I think it's a good thing to put names.
And where is everybody from?
I'm from Covina, California. Oh my gosh. I'm putting my name in the wrong spot.
No worries. There are no apologies needed when we're doing things virtually. We just have to be patient with each other.
There we go.
I'm from Alexandria, Virginia.
Oh, I'm loud. I'm just from right down the street in Fairfax County.
Oh, okay.
Parts, but
Right.
So you'd have to add,
and then I would go throw like, after I got all this done, then I would go start putting, like I would choose a different color maybe and put 2 more circles or whatever till I filled it up and I had 66 wheels used and then I could visually see it.
Yeah, absolutely.
well, actually what I thought, because you did that, is if all 20 of them have, that makes 40 wheels, but we need
Right.
16 more wheels.
Right.
Right.
So since we need 16 more wheels, what I do? I subtracted, what I do? I subtracted 8 from the 20.
Okay.
Hey, do we have,
Subtracted a column.
there they are.
2 times 20.
Hi, group. This is Teresa. I just heard some amazing words, and I'm going to try and script them on
And-
slide 16. So feel free to edit what I do there. I just wanted to get that down. That was amazing.
So because I subtracted, the reason why I subtracted the 8 from the 20 was because I needed to add 2 more wheels to each of those sets of 2.
Okay, would we need to do, instead of 8, would we need to do 13? Because I think we need 26 more wheels instead of 16.
Oh yeah, you're right.
So that would be
Right.
26 and
No, oh, no, no,
36,
no. Yeah, you're right. That would be 26 more wheels. You're right.
and then 13 sets
Right.
of 4. So if I were doing this in a classroom with manipulatives, I would use blocks or whatever, all the
Oh,
same
yeah.
color too,
Right.
and then I would go get a different.
This reminds me kind of the thinking rooms, like with Peter Lozal, where they could see what other people are doing rather
Yeah.
than just, so for people who maybe need some springboard to get started, or students who need that springboard. I think this is great.
It is great.
Hi there, group 3. Or sorry, group 2. Why am I on 3?
Yeah.
There we go. Which manipulative are you all playing around with?
I'm playing with the Cuisinart rods because I haven't used that a lot. So I'm giving that a go.
Fun.
And I joined late, so I guess I'm not even sure how to access the manipulatives.
Oh, so there's a couple on slide 13. Let me make sure you have the link for the slides. What I do whenever I give a task is I choose 5 manipulatives, one or two that I'm pretty confident that teachers, or in the case of kiddos, students have used before, and at least one that I hope is brand new to motivate the techie folks in the crowd who are always interested in a new tool. That way I can, have a diverse group of representations.
Sure. Oh, this is great.
Yeah, the Cuisinart rods are pretty cool because it's very visual and it's awesome just to see that.
There's so much potential.
It seems like it's so much easier, but, you know.
Mhm.
Hello there, group 3.
Hi.
Hi.
I am loving this 66 wheel table, but I could use a little support understanding it. Can you tell me your thinking for this?
I was trying to figure out how many, division by 4s and 2s. So if I had 66 two-wheelers, two bicycles or motorcycles, I would, 33 motorcycles would mean 66, but then 33 spots are not available. So I'm trying to see what combination will add up to 20 spots at the end. So right now, if I have one motorcycle, I can have 16 cars, which is 17 spots. And 3 and 15 will give me 18 spots. 5 and 14, 19 spots. And obviously the next one will give me 20 spots.
So I'm curious, are you able to see in your thinking what is remaining constant and what is changing?
So I started this table by first doing one motorcycle, 2 motorcycles, 3 motorcycles, and then I noticed that I can't really do even number of motorcycles and I won't have enough cars. And so I switched it to just the odd number of cycles, and then the pattern just flowed in.
How cool. And so I'm seeing that your cycles are changing from 1 to 3 to 5, and your 4 wheels are changing from 16 to 15 to 14. But in this table, does anyone see something that is remaining constant that doesn't change ever?
66 wheels?
And
A 4.
you're dividing by 4 right column, and in the left column you are multiplying by 2. I mean, it's I'm not sure.
And somebody said 66 wheels is the constant. How do we see that being a constant in the table?
It's the sum of the wheels in the first column plus the what's the answer? The quotient in the right column.
No, the table itself doesn't do that justice. Like, it's counting the number of vehicles instead of wheels. I do wish I had some way of showing that 2 wheels and 64 wheels and things like that. But how do I show that? How would I show? I don't know.
That's a really great question. I listed a couple variables that we're going to be working with today here in the notes section, and this came from you all. 66 wheels is what I heard you say you think the constant is. And there's other things like the number of vehicles and the number of spots. And so think about all three of these as you're working through all the different models. I'm going to leave that question with you and head into another group.
Thank you.
Brush my teeth.
Okay, well, I'll get them. All right, so we've got it, and then let me just shrink it down to size, and then we can duplicate it. So then we can model for our kids like what that would, like I'll make a bunch of.
Why are you doing that?
To the side. 1, 2, 3, 4, 5. And then we can just drag and drop them into the parking spaces.
Oh, and just try different, they could try different combinations. How did you stack them behind each other like that?
So if you have a lot of images, you can do right click. And if you right click on them,
but they
that's awesome.
All right, group one. I've seen some things change since I was last here. Tell me about those blue circles.
We started with every box had 2 wheels, so we knew we used 40 wheels, and then we just went back and put 2 more wheels for the cars or the trucks, whatever. And so our blue and green is a 4-wheeled vehicle, and we filled it up till we got to 66 wheels, and we were done. And we feel like this.
We also talked about the idea, since there were 40 wheels already, that meant that there were 26 wheels left over. So because there were 26 wheels left over, what we needed to do was to divide the 26 in half, because we only need to add 2 wheels more to each of those. So 26 divided by 2 is 13, which means 13 boxes or 13 spots needed to have 2 more wheels added.
Oh, interesting.
So this is very accessible to young children all the way up to algebra.
Well, now I'm hearing algebra. Is there an algebra teacher in the group here?
No, we sneaked down and looked at one of the slides was putting in algebra equations. I don't remember which one it was.
Yeah.
Oh, I think it's on 23 maybe. And is this a systems of equation problem? I don't remember my algebra.
It is indeed. So they are working kind of in this algebra sense. I'm going to ask, since I know several people in this group pledged the oath, for you all to think of another representation that you could use to show this. So stretch your minds further. There are 5 manipulatives you could choose to use, and we'll see if any one of those other ones helps to make the connection to the algebra.
Okay, let's see. Oh gosh.
To be synchronous, so it's been hard to, I only get them for, about 45 minutes a day at the same time, otherwise they're all on their own, so I don't, trying to figure out ways to get it to show up so I could do this with them.
Yeah, that would be hard. Still working on mine, not getting it right here. Are you guys finding lots of different answers?
Oh, I got the same.
Same answer, okay.
I went like with the spaces available was more visual with the Unifix cubes.
Cool, did you put that in there? I need to go look at it. I took my rods out since it wasn't quite right. I like that one. Whoever has the Unifix cubes, bring that in. That'd be cool to have another visual.
Yeah.
All right, for those of you watching remotely, what I have now are a couple of selections that I would like to use in the math talk here. And I've purposefully selected these, but I might have too many, so I need to start thinking of my questions. The first question I really want to ask is, how do we see one wheel? And I'm going to ask this question on both this slide and also on this slide. So I want to connect these two because I want the representation to be clear. So let me put this same question on this slide. And I also want it down here on this slide. Now, the reason I'm interested in this is fractionally, I see both the set model and then I see area model, and then I see the numeral. And so those are all very important in looking at fractions. And I'm going to color code these so that we can be clear about the red model, the orange model, and the yellow model. Okay. I like this table, but I don't want it to distract us here while we're just looking at the model. So I'm going to take out the table. And I'm going to add it down on this slide. What I'd like them to do is determine if that table matches the graph. So we're going to gear up the rigor into Algebra 1 there. All right, so we've got some different models. We've got some fraction notation on this slide here. This is going to kind of bring us into the algebra. Hi, Sue. I'm going to place you in a breakout room. We are on the task about the motorcycles. In this example, though, they have shared what X and Y are. And they have here also, I'm curious, oh good, their X's and Y's are different. This one has 4X plus 2Y, and this one has 2X plus 4Y. So I really want to get into what is X and what is Y. And the route starts with guess and check, and then it moves into this table, and they can see their guess and check on the table. That's really important because that's going to lead us into what that looks like on this graph. So I want them to be able to talk about this part of the graph, and I want them to talk about this part of the graph. All right, let's see if that happens in our whole group discussion. We have 2 minutes, and then we'll do whole group.
With an equation, I was trying to think about, like I said, in the elementary grades, how students might approach the problem with the visual model.
Very nice. Really parking at that space.
Yeah, I had to have a visual of the parking lot before I could start.
And I think mine was a little similar to that in terms of I actually started with 4 of the cars. So I was like, I'm going to just fill it up with the cars for the 4 wheels. And then I realized I'm going to have way too many, or with 20 vehicles, if they're all cars, I'm going to have way too many wheels. So I kind of backed it off and kept doing some trading. And I was using the Cuisinart rods for that to say, okay, I'll pack as much as I can and then back it off to make the right number.
Oh, so you start out with vehicles?
Yeah, I filled in, like I had the 2 rows of 5, and then I had mostly cars on the second.
Welcome back, everyone, to the main room. Hello and welcome back. Can you believe you've been working for 20 minutes already? And while this problem has so many opportunities to continue finding other strategies and representations, we're going to bring our conversation together and summarize our thinking. If you would come down to slide 25, I use discussions in the way that Smith and Stein talk about them in the 5 practices here. I've already anticipated different strategies and technology tools that I expected to be used. I monitored and literally got your work from you. I didn't use any of my own work here. I selected and sequenced based on purposeful questions I plan to ask so that we can make connections. And I have a couple different connections since you all are educators, where I would probably just stick with one connection or 2 very similar connections with grade school children. So if we begin on slide 26, this is the first of a couple. And I'm going to ask you to take a look at slide 26 and then slide 27. And if you see a way that these are similar or different, please make your voice heard. Either turn on your microphone or write in the chat box. How are these the same or different? So Jerry sees all 20 spaces. They are both visual. And you can see the wheels. Laura brought up they both have a 4x5 array. Raha brings up a difference. Raha, could I get you to elaborate a little bit on that? You said that they are different because they're using different representations. How do you see that?
Sure, Teresa. On slide 26, we decided to show the wheels using circles or like chips or blocks. So the 4 circles represents a car and the 2 circles represents motorbikes. But on slide 27, they decided to use real life clip art to show the 2 wheels and the 4 wheels on a car versus a motorbike.
And Raha, can you tell us on slide 26, I think this was yours, what represents
Yes.
one wheel?
I think one of the circle represents 1 wheel.
So I've typed that in this red box because I'm going to ask the same question on slide 26. And I invite Raha, if you want to use your microphone, go ahead. If anyone else sees it, how do we see one wheel in this representation?
I think they're the tires, but for the cars, we can see 2 tires, but we know that there are 4 tires in a car for it to function.
So we have to use some prior knowledge here of things that aren't even shown. Does anyone else see the idea of one wheel a different way? All right, Laura, you've written 27 and 26 and what they mean. Tell us a little bit more.
So as our group was we were working on slide 27, we were thinking of the clip arts as units, like one of those pictures is a motorcycle and one is a car. So you can't really see the one wheel. You have to know, that's like knowledge that you bring to like previous prior knowledge that you know that a car has 4. But on slide 26, you do see each of the individual wheels. So they're looking at it like from the parts, like the pieces of the wheel, and 27 is looking at it as a unit.
Daria, you bring up a similar reason Do you have anything that you wanted to add to what Laura had just said?
No, I think she represented, I think she was great with it. Yeah, so then if you look at 26, you are really representing the wheels and how many wheels can go in a spot. But then in 27, they're representing the types of vehicles in a spot.
Excellent. So these are really important ideas as they evolve into kind of what we're talking about and how we use it. In slide 28, we have two more representations. We'll call these the green representation and the yellow representation. And I'm curious if you all have any connections from the previous ones. So give us a minute to digest these. These are quite complex. And if you have a connection to share, you can use the chat box, but sometimes it's easier to raise a hand and use your microphone. So Lisa, when you see the jumps in the green one, does that remind you more of slide 26 or slide 27? And why do you think so?
Let me look. It reminds me of slide 26, which we worked on, because I can go back and count the fours, and I see the 4 jumps, and they had 13 4 jumps, and in ours we had 13 boxes in the array with 4, and then they dropped down to the 2, which matches the boxes with only the 2 wheels.
Oh, so you can really see those 4s and those 2s.
Yes, you can.
Lovely. Thank you for stating that. Is there anyone else who wants to either rephrase that or phrase it differently for our yellow model?
So on slide 28 with the yellow representations, I'm also seeing the 2 jumps or the 4 jumps, but they're just represented using numbers, which is more abstract versus on a number line where it's visually more concrete.
Yeah, so the number line, we get to see every number. And here with our numerals, it is very abstract.
Teresa, I want to mention on the side, they wrote 66, no, can't do an even number of motorcycles. And did they determine that after they got their cars or before they got their cars?
You know what? What a great lead in. So I want us to consider this. This group did say it. We can't do an even number of motorcycles. And with our next group, we're going to look at how they did guess and check and keep that question in mind. We'll come back to it after slide 29. So on slide 29, would someone from our group 4 tell us a little bit about kind of this yellow arrow and what you did and how it led to the orange arrow, please?
For the, I used the Cuisinart rods, and I started with the 20 vehicles and those 20 spaces, and then I had too many wheels at that point, so then I swapped out some 2s for the 4s, and I still had too many wheels, and then I got to the last one, which had the yellow box around it, where it does have 66 wheels, and then I'll turn it over to one of my colleagues to share the table and then some connections.
I use the table because I'm just trying to find out with the information that the total number of wheels is 66 and total number of vehicle is 20. So kind of like systematically tried it out. And then I tried, whether I can use 2 motorcycle and it didn't work. And at the end, I talked in our group saying that, that is interesting. How come I cannot have even numbers in the column, in the number of motorcycle column?
Yeah, so somebody who is not a part of this group, did you also find that motorcycles had to be odd? And how did you think of it? And feel free, anyone from any group, why do you have to have an odd number of motorcycles? Why can't it be even?
I doubt that this is like where you're going with this, but the way I thought of it was I just took the number 6, because it's 66, and I thought that's got to be 3 motorcycles. That makes up the 6 out of the 66 wheels.
So you saw that 3 and that 2 and that 6?
I guess so.
I think also I was thinking that with the number 66 wheels, it couldn't be a number of cars because 66 isn't divisible by 4. So I'm thinking about how that might relate.
Ah. So if we use some division, we're going to get remainders. Go ahead, Lydia.
So if you go back to slide 18, I was trying to see how to show this idea that, you can have even number of motorcycles. And so, like, I tried to play around with the Unifix cubes. I have not used it before, but then I could see that if I took out one of the red cubes and added it to the yellow, which is my motorcycle column, I'd have to add 2 yellows. So the odd and the even kind of just, I don't know if it makes sense. But using the Unifix cubes, I thought I could see how the motorcycles always remained even.
So visual models are very useful in this idea of splitting and combining. Let's hear from Naomi. Go ahead. And Naomi, if you do want to turn on your microphone, we'd love to hear from you. Take your time, though.
I was thinking similar to what you just talked about, that the cars is going to be even, and whatever is left over, you're going to have to, it's going to be an even amount, because you're going to take 66 is even minus an even number is going to leave an even number. And then whatever is left over, you have to divide in half. And anytime you divide an even number in half, you're going to get an odd number.
So we could even get into discussions about always, sometimes, and never with division and multiplication of even and odd numbers. There's a whole fun unit about that one too. All right, so there are a couple of important things that I do want to make sure that we address here, and that is this problem has been seen in kindergarten and first grade classrooms as Farmer Bob, where we look to see how many legs are out there in the farm. Some animals have 2 legs, some animals have 4. But this problem was taken out of the Virginia Department of Education's Rich Task for Algebra 1. So let's see the algebra that is coming out of this problem. I'm going to have group 5 take it over on slide 30 and talk to us a little bit about the algebra that's happening.
Okay, well, that was my slide, and I do teach Algebra 1 in high school, and so we use problems similar to this when I'm teaching them how to solve equations. And so on my slide, I started off just how I would do it in the class. We would look at the problem, and then I would say, okay, well, think about how you would set up your equations. And so first we would define our variables. And so I used X and Y just to make graphing easier in the application I'm going to use. So I'm going to let X equal the number of motorcycles, Y equal the number of cars. What do we know? We know that the total number of vehicles, the number of motorcycles and cars equals 20. So that would be good. And then we also know information about the total number of wheels. We know that every motorcycle has 2 wheels, and so that it'll be 2 times X. Every car has 4 wheels, it'd be 4 times Y, and the total number of wheels was 66. So we have 2 unknowns, X and Y, and we have 2 equations, and so now we're able to solve for it. And so then, oh, do you know what? I'm sorry, my slide is messed up. So this should be X and Y. I guess I used M and C at first, but then I knew that the students would get confused if they were
you know
graphing
what?
it.
That was a beautiful
So
little.
then I use a package called a software product called Desmos. We use that for our graphing and our SOLs and things like that. So they would be able to go into Desmos, put both of those equations in. I would tell them that the red line represents all possible combinations of X and Y that would add up to 20. So you could see you could either have no, I'm looking at my, you could either have no, what was my X? No motorcycles in all cars, or you could have no motorcycles, no cars and all motorcycles. And so that represented the Y, and then the red line. And then the blue line, that was all the combinations of wheels you could have. So that would be you would be able to follow the blue line, and then where they intersect, the intersection point, that's the solution to that system. That shows you that's the only possible answer that would meet the constraint of how many possible vehicles and how many possible wheels. Okay, is that good?
Yeah, that's quite lovely. So this is a very rich Algebra 1 topic. My question to you all is, and this is really for everybody, if you could respond in the chat box, what does the pink area mean and what does the green area mean? If you happen to know those, think for a minute, and you can write in the chat or you can use your voice. Those 2 sections are also very important. What do they mean? And Daria, could you give us an example of one point within this pink area? Like what would a point be that students would know or it lies there?
Okay, so a point in the pink area. Let's see. Oh, sorry about my dog. I'm trying to find a whole number. Okay, so one of the points I will give I can use that point 0, 20. So that represents 0 vehicles and 0 motorcycles and 20 cars.
So 0 motorcycles and 20 cars is getting close to, on slide 29, what this group had done in their table. And so the neat thing here is now we can start to relate tables to this pink section and this green section as well. So now we can take other people's models and we can start to say, when we have too many wheels, is that represented in the pink area or is that represented in the green area? And what we can do is we can start to give visual representations to these very abstract graphs. And that is what algebra is all about. We are at the top of the hour, so I do want to thank everyone for coming here. But I will say after, if you have any other questions about the mathematics that we've talked about and also about the technology. As a reminder, on slide 32, I do MATHurdays every Saturday. We do a new routine, a new rich task. The sign up for next week is now available. if you would like to go to Eventbrite and sign up. And also, I have a book coming out next month called Teaching Math at a Distance. That link will take you there. Slide 33 are other links you can go to for templates and recordings. And I have some frequently asked questions and more. And I'm going to hang out here in the virtual parking lot for anyone else who just wants to chat about the math or the technology or how do you do this with kiddos. But it's been a pleasure. Thanks for coming to MATHurdays, and have a happy Saturday. Somebody said, how do you use the 10 frames and then copy them into the slide? So I'm going to share my screen to showcase how I would do it, and I'll invite anyone else if they have ideas to do it also. So here's the 10 frames. This is a virtual manipulative through DideX. I might use the 20 spots, put in some motorcycles, put in some cars, and then when I'm ready to bring this in, I'm going to do a screen capture. So screen captures, I'll teach you how to do it here, but the nice thing about a screen capture is I can say I want this, click over to our slide, and then paste that directly on the slide. And screen captures are done a little differently depending on what type of computer you have. So I'm going to put directions on slide 37. If you have a Windows, it is the Window button, which is next to Control and Alt, the Shift, and the letter S. And then you'll be able to drag and make that little connection. Mac, oh goodness, I think it's Command Shift 4. I'm not a Mac user, so if there is a Mac user, can you verify that one? And Chromebook.
Yes, that's correct.
Thank you. Chromebook has a dedicated button. I'm going to just grab the image of that. There is a special little button on the Chromebook. Oh, the little heart image isn't in the top one anymore. So that is there if you happen to have a Chromebook. Other questions. How do you get more students to participate even when you give a generous amount of think time? Options are microphone and chat, but still not participating. And someone said, my question is similar. How do you hold students accountable for talking and working on the rich task? How do you build that culture virtually, especially when there's pressure of pacing and time? So there's a couple of things that I do here. And one of them you may have seen in the MATHurdays, but I also want to be very explicit about it, that I personally value very different ways of seeing mathematics. So if somebody has an equation all written out that is traditionally kind of looked at as the quote unquote mathy way, but if I want students to come up with a lot of representations, I need to also show that I value that, and that's what we're going to talk about in the whole class discussion. So part of it is the valuing of the different models and connecting those models to the equations. Other things that I'll sometimes do is start kids off in small groups during, let's say, office hours or small group times, if that's available, where they can kind of walk through it with me. Hey, does anyone know how to use this manipulative? And they're like, no. I'll say, well, let me go into another group. If you guys can play around with it and teach me how to use it, that would be great. So now they're in the number line and they're trying to play with it. And I'm like, okay, well, how do I show 4? How do I show 2? How do I show these jumps? And when they start to teach me, they're also starting to uncover their own like kind of genius in using the app. And then I'll say, okay, you're going to be that app's like the expert in it. So even though I give 5 to the group when we do a rich task, like, can you all maybe start with that one and be the expert and be ready to share with everyone how it's done? Once I have 5 groups who are experts in 5 different things, then I make heterogeneous groups the next time. So one person from each of those expertise are now in a group, and they can help with the process of choosing a tool over another tool or bringing the connections in. But a lot of that is play and valuing. How do you teach the students to do a screenshot? I do give them these cues that I have on slide 37, and I make a really fun one where I'll ask them to maybe take a screenshot of something silly they've done. I also ask them to use the camera tool first, just so that they can see how to insert things. So if you go to Insert Image Camera, oh, my camera's laying on my desk. Hang on. I almost never really use it unless it's for the math. I'm going to go to Insert Image Camera and put up a funny image of me. And then that kind of teaches them that, oh, we can put images up, which is super useful when they're doing work paper pencil. And so once they're like, gosh, this is great getting my paper pencil up, and then they have the desire to want to put the online manipulative up. So they'll start to say, how do I do that? And I just teach them these exact things. I'll put them in groups for people who have Windows machines, Mac machines, or Chromebooks, and they take screenshots together. For cloning, I'm happy to go over it as at the same time, but let me put this link in so that you have this. But to clone something, let me make a fun shape. I like this little polygon maker. All right, we got some funky little shape here. And if I want to clone it, I'm going to click it and press Control D several times, or Command D. I'm going to use my drag select to grab them all. Oops, I got that text box. Take that one out. There we go. I'm going to right click, align horizontally, right click, align vertically. Now they're all stacked together. It's not a true clone. I mean, there's only like 13 or so here, but I just make sure there's enough for everyone. Yeah, Daria, the insert image from camera is really, really useful. I think you were the one who said you teach Algebra 1. When students are doing, let's say, substitution or elimination for this system of equations here, I want to see their work. And so they can really quickly show it to me up on the camera. And I can use that to see, like, did you pick X and did somebody else in another group pick Y? And how do our, our methods look different? How is substitution different from elimination? How is it different from trial and error and making it a table? And we can have all of those side by side, which is super nice. I think I've answered all of these. If you all have other questions, feel free to turn on your mic, but definitely go out there and try some of these things out and keep the thinking front and center because we can do this online. All right, everyone. Happy Mather Days. Have a great Sunday.